All right, suppose that we're given this closed contour C consisting of an ellipse, and we'd like to define this function by this closed loop integral, okay? And we're interested in finding g of 1, g prime of I, g prime prime of negative I. So the very first thing that I want to do is graph my ellipse. All right, so this is in the z-plane. The ellipse has a maximum value of x, which is 2, a maximum value of y, which is 3. So it's going to look like this. All right? My points, 1, I, and negative I, are all inside my contour. All right? So for that reason, as long as z is inside contour C, g of z is equal to, is there a 1 over 2 pi I or not?
No.
Okay. So g of z is equal to 2 pi I. And then see what we've got here? This is f of zeta divided by zeta minus z d zeta. So that's 2 pi I f of z. Our f of z here is z squared minus z plus 2. So g of 1 is equal to 2 pi I times 2. 1 squared minus 1 plus 2. G prime of I is just 2 pi I times 2i minus 1. G prime prime of negative I is g prime prime of everything inside C, and that's 4 pi I. All right, here we're just using Cauchy's integral formula to determine the value of this integral as a function of z.